Hello students, welcome to Food Science and Technology 1. I am Dr. Vusim Shaisa, and today we are going to continue on the chapter on composition, nutritional and functional properties of food. We've already discussed in class what is food and what are the functions of food. We also asked the question, are all foods acceptable? So let me start with something very simple. Think about the foods that you eat every day, be it yogurt, polony, bread, custard, or even whipped cream. Now here is the question. What makes these foods have such different textures? Why is yogurt thick? Why is polony firm? And why is whipped cream light and airy? The answer lies in something we call functional properties of proteins or techno-functional properties of proteins. So today we are not focusing on nutrition, we are focusing on what proteins do in the food. So now nutritional properties relate to how proteins contribute to human health when consumed. These properties, they focus on how proteins are utilized by the body for growth, repair, and maintenance. So I normally say to students, nutritional properties answers the question, what happens to the body when we consume the protein? Functional properties or techno-functional properties, on the other hand, relates to or describes how the proteins behave in food systems, how they influence texture, structure, water retention, and stability in food processing. So the functions of a protein in food systems, they are influenced by the shape, the size, the net charge, and importantly, the environment, such as the pH and the temperature. This is why the same protein can behave differently in milk, meat, or in baked products. For this class, we are going to focus on 5 key functional properties. Solubility, which is important in infant formulas. Gelation, which is important in products such as gelatin, custards, poultry products. Water binding capacity in dairy meats, frankfurters, yogurt. Emulsification, ice cream, liquid creamers, salad dressings. And so you can also see that each functional property may be important in more than one type or one kind of a product. Let's start with solubility, because this is often the most important one. If a protein is not soluble, it cannot perform many of its functions. For example, we know that milk proteins are highly soluble, especially in acidic environments. This is why when we use them in fruit juices and flavored beverages, which are popular in the context of South Africa. Now, if you compare that with keratin, keratin in hair is completely insoluble. Collagen is also largely insoluble in water. So already you can see that not all proteins behave the same. So in meat products, you've got soluble proteins that help bind ingredients together. This is critical in products like polony, sausages, and reconstructed meats. So without solubility, you would not be able to have a stable product. So protein from milk, specifically casein, is sometimes used in fruit juices and carbonated beverages. This is because of its unique solubility properties. So you have casein that has the ability to form stable colloidal suspensions, which means it can disperse evenly throughout a liquid without clumping or separating. So you see, this important property is useful in beverages where maintaining the consistency in terms of texture and appearance is important. Additionally, we can also say that casein helps to stabilize emulsions and prevents the separation of oil-based flavors or additives in the beverage. Therefore, by using milk protein, beverage manufacturers, what they do, they can ensure that their products remain visually appealing and maintain a smooth texture over time. And then we go to gelation. A gel is a three-dimensional network that traps in water. And the examples that you already know include custard, yogurt, and gelatin desserts. These are known as gels. Even cheese and some meat products, they behave like gels. When proteins are heated or they are treated, they unfold, and in that unfolding, they form new bonds, creating a new network. This is why eggs can go from a liquid to a solid when they are cooked, and then also if you've got custards, it thickens when it is heated. So gelation is really about structure formation. Now we move to water binding capacity, which is extremely important in the food industry. So this refers to how much water a protein can hold or retain. So this refers to how much water a protein can hold or retain at any given time. Now, for us to think about this practically, in the context of South Africa, we think of products such as polony, Viennas, deli meats, and these they depend heavily on water retention. And then you may ask the question, why is this the case? This is because water binding capacity improves the juiciness, it improves the texture, and let us be honest, it also improves the yield and profitability of these products. If water is lost, we get what we call drip loss. In other words, dry products and unhappy consumers. So this protein binds the water through hydrogen bonding. So the key concept here is that the structure of your product is going to determine the function. So if I want to bring this chapter together, so I would ask the question, what is the big deal here? So the big deal here is that proteins are not just nutrients. They are functional ingredients. They control the texture, they improve stability, they influence sensory quality, and then in South African food systems, from dairy to meat processings, these properties are essential for product design. So as you move forward with this course, I want you to start looking at food differently. When you eat yogurt, ask yourself, what protein property is at work here? When you see polony, think about water binding and gelation. That is how you start to think like a food scientist. Thank you.